In this problem, they tell us that the concentration of a drug in the body decreases exponentially after a dosage is given. In one clinical study, adult subjects averaged 13 micrograms per milliliter of the drug in their blood plasma 1 hour after a 1,000 milligram dosage, and 4 micrograms per milliliter 5 hours after that same dosage. So we want to find the value of K and write an equation for an exponential function that can be used to predict the concentration of the drug. So they gave us two scenarios. They gave us what is happening at t equals 1 hour. Then we have P of 1 is equal to 13 micrograms per milliliter. And then they told us that when t is equal to 5, after 5 hours, then the amount of drug is 4 micrograms per milliliter. So these are the two scenarios that we know about. The equation is going to be in the form P of t equals P naught e to the kt, where k is what we're trying to find out, and that is the rate of decrease. So let's see, what do we know? We know that P of 1 is going to be P naught. We don't know how much we started with. We don't know K, but we know that T is equal to 1. And we know that turns out to be 13. And I also know that P of 5 is P naught. Still don't know what that is. Still don't know K. But that calculation turns out to be 4. So what I'm going to do here, I want to find K. I'm going to solve each of these equations for P naught. And I can say P naught is equal to 13 over e to the k. And I can also say, from the second scenario, that P naught is equal to 4 over e to the 5k. Okay. So now, since the P naught is the same, that's the initial amount, I can set those two quantities equal to each other and solve that equation. So I have 13 over e to the k is equal to 4 over e to the 5k. And what I'm going to do is I'm going to multiply both sides by e to the 5k. E to the 5k over here, squeeze that in. So I have 13 e to the 5k over e to the k. Keep those e to the k things on the same side there, and that equals 4. And then I can multiply both sides by 1 over 13. So I could have done this in the same step, just whatever you prefer to do. And on the right side, I just divided by 13 instead of multiplying by 1 over 13. So those 13s cancel, and e to the 5k over e to the k is now e to the 4k. So if e to the 4k is equal to 4 over 13, I can take the natural log of both sides, and 4k comes out front, and that's natural log of e, so that's just 1. So 4k is equal to the natural log of 4 over 13, and then I just divide both sides by 4, or multiply by 1 over 4. And when I calculate 1/4 times the natural log of 4/13, I get negative 0.295. Okay. So that's the value of K, and we've got that there. And then we need to know which is the correct equation. So once I know that that's negative 0.295, then I'm going to, let's see, what's the easiest way to do this? I want to know what P naught is. So I can plug in here, and I can say, well, P naught is going to equal 13 divided by e to the negative 0.295. And that turns out to be 17.5. So that's how we get that equation. And then in the next part, it says, what is the concentration of the drug after 4 hours? So I'm going to go to the next page. Okay, so I have my formula, P of t equals 17.5 times e to the negative 0.295 t, and we want to know what the concentration of the drug is after 4 hours. So I'm going to do P of 4, 17.5, e to the negative 0.295 times 4, And let's see what that is. Okay, so this turns out to be 5.4. So that's going to be the answer here, about 5.4 micrograms. And then in part C, it says to relieve a fever, the concentration of the drug should go no lower than 2 micrograms per milliliter. So we want to know how long will it take to drop to that level, and then I guess you take more of whatever that is. Okay, so now I know what the concentration should be. So I'm going to take that formula, 17.5 e to the negative 0.295 t, and set that equal to 2. I can divide both sides by 17.5. And this is e to the negative 0.295 t. And then take the natural log of both sides, as we so often do. And I get negative 0.295 t is equal to the natural log of 2 over 17.5. And divide by a negative 0.295. Wow. And what does that equal? Okay, that turns out to be about 7. They have you round that to the nearest whole number of hours. So about 7 hours, and you should take more of that drug, whatever it is. All right, that's how you do that problem.